Okay, here is some information about doing our capacitor lab. We're going to use from your kits, we're going to use the multimeter, your battery holder, and then in the plastic bag you'll find capacitors. There's a few of each kind. We're going to find one that's marked 470 microfarads and another one that's marked 220 microfarads. And then we're going to use these two resistors, these large brown colored ones. And that should be all we need for that. So what we're going to do is make a circuit that connects the battery to, first of all, to one of the capacitors. And if you look at the capacitors, you're going to notice that they have a strip. Hopefully you can see on this, but there's this white strip on one side that has little negative signs on it, and that's the side that goes to the negative of the battery, and the other side is the positive. So I'm going to find that white strip side, and I'm going to connect that lead, that wire, to the negative of the battery, and what I'm going to do is just twist the two wires together. Probably when you get this battery holder, at first the plastic coating will go all the way to the end of the wire, so you have to strip off some of that. If you have fingernails, you can kind of just pinch that plastic coating and yank off a piece of it, and hopefully not break the wire itself. If that doesn't work, you can take a pair of scissors and just gently cut the plastic coating, or a knife, and gently cut the plastic coating and try to pull off about a ½ inch of it without cutting the wire. If the wire gets broken, that's okay, you can just try again. You'll get experience with that, which is useful experience. So then I'm going to take these two wires together, and I'm going to make like a little Y shape out of them and twist them up a few times so they stay together. And I got the negative on the negative, and then I'm going to take one of my resistors and make another sort of little Y shape with those two and twist them up a couple of times so that they stay together. And I'm going to connect the other end of the resistor to the red, which is the positive of the batteries. Okay, like that. It helps if you separate them out a little bit and then twist them up. You don't have to twist them up too much or else it's hard to get them apart, but enough that they'll stay together, make a good connection. Okay, so there's my little circuit, and you can draw a picture of that circuit that helps you understand the circuit. And then I've got my batteries. I'm going to put one battery in the connector, and then have another battery ready standing by to put it in the connector when I'm ready to start measuring things. And I'm going to take my voltmeter and turn it on to DC volts. And what we're interested in is the voltage across the capacitor. So I'm going to put my two leads, one on each side of the capacitor, and I remember that I want to put my black one on the negative side, the downhill side of the hill, and I'm going to put my red one on the uphill side of the hill, like that. You see that? Yep. Okay, and now what I want to do is I want to make sure I start with a discharged capacitor, and if I look at my voltmeter right now, it looks like the capacitor is not discharged. So in order to discharge it, I can either take some other metal thing or a screwdriver, or just touch my two leads together and you see it goes to 0. Okay, you just want to start out with it 0, meaning it's not charged at all. Right, the voltage on the capacitor is one way of measuring how much charge is on the capacitor because they're related. And sometimes it'll get charged up from just sitting around, so I'll just discharge it. Okay, so the lab, what we're going to do is we're going to study how fast this capacitor charges up as I apply the battery voltage. So there we go. So what I'm going to do is I'm going to connect the battery in the case. But before I do that, I'm going to get ready to take data, and you're going to take data every 10 seconds and write down or type in an Excel or something the voltage on the meter every 10 seconds. And it'll be changing fast, so you won't be able to get it exactly perfect, but don't worry about it. Just write as good as you can what you see when your 10 seconds comes up, right? And we'll do that for like 3 or 4 minutes until the voltage reaches this sort of steady state. Okay, so what I'm going to do is take my battery and clip it in there, and you'll see my voltage starts going up, and I'm going to record voltage every 10 seconds. Okay, so that's that. And then once I have the circuit all set up, I don't want to discharge my capacitor now. Say it's all charged up. Now I'm going to remove the batteries, and I want to take data again with discharging the capacitor and see how the voltage changes over time when I'm discharging the capacitor. What I want to do is connect the wires together so that the electrons can flow, the charge can flow from one plate to the capacitor to the other and discharge it. So what I want to do is basically connect this red wire to this black wire. And then as soon as I do that, start taking data. So what I'm going to do is just kind of put them close together, and then and remember I told you about being careful not getting shocked by a capacitor, but we're at such low voltages with these little batteries that there's no way you can get shocked by the capacitor. So one way you can do it would just be to take those and pinch them together, and you can see the capacitor starts discharging. You could also take the alligator clips, one of your alligator clips from your kit, and clip the wires together, and you see the capacitor starts discharging. And so you're going to want to do that, and again start from a charged capacitor and take data every 10 seconds until the capacitor basically drains down to almost nothing. And you'll be able to plot these graphs. Okay, so charging capacitor, discharging capacitor, and then you're going to change a couple of things. You're going to change the resistance and the capacitance. To change the capacitance, you can just replace the one capacitor with a bigger capacitor. It won't be a lot physically bigger, but it'll have a bigger number on it. And the way we're going to change the resistance is a little trick. If I'm trying to have water flow through one hose, or if I double the number of hoses, then I can get water to flow faster, right? So what I'm going to do is take these two resistors, and I'm going to twist them up together. And you have to be careful when you're twisting these wires, because if you bend them at the resistor itself, it could break, and we only have a certain number, so just be careful with that. But I'm going to twist these a couple times together at that end, and then I'm going to twist them together at that end, and now I have sort of double the width of my hose, right? So that's going to make our resistance go down, and you can double check that with your So remember, as I'm trying to undo these things, I'm noticing if I twist them too many times, it's hard to undo them. So don't twist them more than you need to. And be careful again that you don't yank on these wires, because if they break, then you lose that piece of equipment. So you'll learn how to twist gently and carefully. We also have these little blue things in your kit that are called wire nuts, and they actually work pretty well with the fatter wires. So if instead of wanting to twist these two resistors together, I could just hold them together and screw this wire nut onto that, put it on there and twist, and that should hold them together like that. So I'm going to double check that these two resistors twisted together have I just told you that they should have half the resistance of one resistor, so I'm going to double check. What I'm going to do is set my meter here on to measure resistance, and then you can clip on either side of those and see what resistance it says, and compare that to what it said when there was just one resistor. Okay, so we're going to be taking data for basically 6 sets of data, discharging and charging, and with different capacitor and a different resistor. And then using that data to answer some questions. Okay. Here I'm going to show you how to use the battery holder to get a different voltage, so you can cut your voltage in half, right? If you put 2 batteries, you'll notice that you get twice the battery voltage because they add up in this situation. So one way we can get a different voltage is just get 1 battery's voltage instead of 2 batteries' voltage. And so what I'm going to do that is I'm going to put a battery in the clip like that, so that it's connected to the black wire at this spring. You can see if you look in there that the red wire is connected to this terminal, so I'm going to put the battery so that its end is connected to the black wire. And then on the other end, the positive end is connected to here, but it's also got a wire that goes across and connects it to this spring. So this spring will be connected to this end of the battery. So I just have to connect to that spring, and then I can get 1 battery in there. So I'm going to take the red wire from my kit. So I'm going to take my scissors and cut a little groove into the plastic coating, maybe rotate it around to get it to go all the way around without cutting the wire underneath. If you get it right, you can pull that wire off. So now I have a bare end of the wire, and I want to connect it to this spring here. And I have an alligator clip in my kit, so I can just kind of clip that onto the spring so that it makes a good connection. And now I have a 1 battery. It's a little tricky to do. And now let's make sure it makes a good connection. And now I have a 1 battery power supply from my black to my red. And you can use the voltmeter to measure the voltage to make sure it worked and what the voltage is.